Good evening. This is going to be a response part 4 of this sequence of responses. Now, for this one, I want to just drill into this hypothesis of relative density. I want to make sure I absolutely, completely understand what you're saying because, just to explain, from my point of view, I was taking relative density to mean something quite different from what you are saying. I've been saying all along that there is an external vector that gives us the direction that things move, and I've been showing how that's related to acceleration. You, on the other hand, are saying that it is the density gradient that is the cause of how things move. So I know you've answered this. I want you to be very, very clear with me right now. So I'm going to go through very carefully what I understand from your hypothesis, and I want you to correct me about anything that I misunderstand. Let's be absolutely clear so that we're totally on the same page, and then after this, we will design experiments and test the hypothesis. So please lay out for me exactly, is this correct? I want to try to be as precise as possible so that I do not misunderstand you. Again, the idea here is that if you can be completely clear with this, we should be able to create experiments to test this as a formal hypothesis. So here we go. To begin with, any object moves toward the location within the medium that matches its density. So to clarify, dense objects move toward wherever the medium is denser, and the less dense objects move toward the location within the medium that is less dense. So objects will come to rest where their density matches that of the medium they're in. Again, we are expecting that there's a density gradient within the medium. Like in the air, the densest air is at the bottom, and the air up on top of the mountain is much less dense. So if you release a helium balloon, it will move up towards the less dense air, which is up, right? That is the core of the hypothesis. And to be very specific with it now, the direction of force is going to come from the direction of the density gradient within the medium, meaning that it is dense air at the bottom, it is less dense up the mountain, and so the helium balloon is driven towards the less dense. We could measure the density gradient within the medium, measure where the density is different within that single medium, and then the way the object moves will be along the direction of that gradient, which normally here on the ground is densest at the bottom and least dense up at the top. Okay, next point. The density of the entire object is the density that is considered, not the density of the individual materials that the object is made out of. What do I mean by that? I mean, in all of these cases, we are considering pretty much a single material for the medium, but the objects are often composite objects. For example, a helium balloon is actually a latex skin that has been filled with helium. And the density of latex is certainly greater than the density of air, but when combined with the helium, the complete helium balloon, consisting of both latex and helium, is less dense than the medium of air, and therefore it is driven to the location of minimum, of matching density, right, which is up in a typical gradient. Okay, and finally, despite what we just said about latex, the object must be in contact with the medium for this effect to occur. And my example here is that if you're in a submarine under the water and you drop a basketball, the basketball is in air. It's in a pocket of air contained within the submarine. And so the medium that the basketball is in contact with is air, and the water above the submarine cannot affect that in any way. Okay, so I think that's our hypothesis. That's our complete hypothesis. Please tell me if there's anything here that is incorrect, that you do not stand by, that you do not want to test. We are going to design an experiment to test this hypothesis. And so I want to make sure that I'm not making some kind of straw man here, that we are being very clear about exactly what we're saying. And this is the big question right here. And that is the density gradient the cause or is it the effect? The hypothesis, the relative density hypothesis, is suggesting that the density gradient is the cause of how objects move. That when you release a balloon, it will move according to the way the density gradient is. The null hypothesis is what we call it if that's not true. It's the other way, and that would be that this density gradient we observe is not the cause of objects moving, but is in fact the result of something else. Perhaps the density gradient is the result of the same external influence that causes the helium balloon to move. So these are our two options. Either relative density says that the reason the helium balloon rises is because of the existence of a density gradient. And if that is not the case, we will be trying to show whether that is the case or the opposite, which is that even though the density gradient does not already exist, we can show that the helium balloon will move in a particular way. So if I have all of your points correct here, we'll start to design some experiments. We'll conduct those experiments and find out if your hypothesis holds up. Before I do, the main reason we're doing this, why we're going through this exercise of being extremely careful to get everything right, is I want, before we do the experiments, I want to agree what those experiments mean. If we design an experiment based on this hypothesis and we invalidate the hypothesis, what does that mean? It's a really good exercise to try to fight your own internal biases, to decide before you do the experiment what your response should be to the null hypothesis. I don't think it's appropriate to completely throw out your hypothesis just based on a single experiment. Maybe we should do multiple experiments. How many experiments does it take before we declare that the hypothesis is definitely invalid and we need to rethink this whole situation? I'm looking forward to a response on those points. Whether I've got your hypothesis correct on every point and what your responses should be if any experiment invalidates any point of that hypothesis. Okay? I'll talk to you soon. Thanks.